Today we're taking a look at section 8.9 on linear inequalities, systems, and linear programming. First of all, a linear inequality in two variables can be written in one of these forms. Ax plus by is less than c, ax plus by is greater than c, ax plus by is less than or equal to c, or ax plus by is greater than or equal to c. Now, we're going to be working with graphing in order to be able to solve systems and also do linear programming. So when we're graphing the first two inequalities, our boundary will be a dotted line. When we do the last two, our boundary will be a solid line. So the dotted lines means we're not including the line. The solid line means that we are including the line in our graph. So our process to graph a linear inequality, we want to draw the boundary, either dotted or solid, depending on which type of inequality we have. We choose test point. We check the point in the original inequality. If it makes it true, then we shade where the point is located. If it makes the original inequality false, then we shade the opposite side. And I have two here that I'm going to do on this section of graph paper. Okay, so we draw on our y-axis and our x-axis for the first one. And we have x minus y is equal to -3. Okay, so I'm going to put 0 in for y. That means x would be a -3. Basically what we're doing is we're looking at x minus y equals -3. And then if x is 0, y would need to be a +3. So I'm using the two intercepts. Let me mark some units on here. -2 and -4. Okay, so we have -3, 0. and 0, +3. Now, the inequality is greater than or equal to, so we're going to use a solid line. And I'm going to choose 0, 0 here as my test point. If I plug 0 in for x and 0 in for y, I get 0 minus 0, and that's going to be a 0, is greater than or equal to -3. So that is true. So I want to shade the side of the line where 0, 0 is located. So it's located below the line to the line to the right. So my solution set is the line plus all of the shading that we have. Okay, next one, we want to graph y equals x for our boundary. Let me get my x and y axes in here. Okay, so we could use 0, 0, 1, 1, 2, 2, 4, 6, 2, 4, 6, -2, -4, -2, -4. Okay, so 0, 0, 1, 1, 2, 2, -1, -1. Okay, now as I look at this, I see, y is less than x. That means I need a dotted line. So let's make it look dotted. Okay, so we have a dotted line. And now we need a test point. I'm going to choose 4, 0. So x is 4, y is 0. 0 is less than 4 would be true. So I'm going to shade. Notice we couldn't use 0, 0 here because it is on the line. Okay, so we had to choose something not on the line. Alright, so that's how we work with basic inequalities. Now, why do we want to know about grading, being able to graph, that is, inequalities? Well, graphing is used to solve systems of linear inequalities. Systems play a part in linear programming, which is a type of problem that sometimes crops up in business. So we're going to take a look first of all at a system of linear inequalities. And what we do is we graph each inequality in the same coordinate system, and we find the intersection of the regions. That will be the solution to the system. So I have a system listed here. I have two equations. So let me set up my coordinates here so that I know. 2, 4. Okay, that'll be fine. Alright, so our first inequality is x minus 4y is less than or equal to 6. So I need to look at equal to 6. I want a solid line for this because it is less than or equal to. So I can, let's put a 0 in for y. That means x is 6. And if we put a 0 in for x, negative 4y equals 6. Y equals negative 6/4. So y would be negative 3/2, which is 1.5. Okay, so 6, 0, 0, negative 1.5. And it is a solid line. Okay, I didn't quite go through that point, but alright, so y is greater than or equal to 1. Alright, y is greater than, I need to shade this one before I go on. I'm going to indicate where the shading would go, but I'm not actually going to put it in here. So if test point 0, 0, 0 minus 4 times 0 is less than 6, so I know my shading's going to go up. I'm just going to point the direction for now. Alright, y is greater than or equal to 1. Here's y equal to 1, and it is greater than or equal to 1. So that would go up. So now what we want is where we, and that would be up, where we have both types of shading. And that's going to occur where we have the intersection of the two graphs. And that's going to occur, let me see if I can shade it in yellow. Okay, and that's because we're going to have this. I'll just go ahead and put in lines for the one going this way, and lines for the other going this way, kind of. So where the two intersect is that yellow region, and that would be the solution to the system of equations. Okay, now we're ready to do an application problem. Our linear programming problems, we first write all necessary constraints in the objective function. We graph the region of feasible solutions. We identify all the vertices of that region. We find the value of the objective function at each vertex. And then finally, the solution is given by the vertex producing the optimum value of the